Hello everyone. Today we are going to solve Leetcode problem number 56, merge intervals. We are given an array of intervals. So each interval is going to hold two values, the start time or end time. We can take it as a start and end. And we need to merge all the overlapping intervals and return an array of non-overlapping intervals. Okay. So if we take an example, so each intervals are given like this: 1, 3, 2, 6, 8, 10, 15, 18. Okay, so if I take this example here, assume that these are like meeting intervals that we have got. Okay, first meeting is going to start at 1 and then it ends at 3. Okay, and we have another meeting which starts at 2 and ends at 6, and the third one which is going to start at 8 ends at 10. The fourth one, it's going to start at 15 and it's just going to end at 18. Now if you look at all these intervals, we can clearly see that there is an overlap for these two intervals. Okay, so 1 to 3, 2 to 6, we have to convert this overlapping into a final interval, which is like the start time is going to be 1 and the end is going to be 6. So that will be our final interval. Okay, and for these, as there are no overlappings, so they will be like 8 to 10 and 15 to 18. Okay, so this is going to be our final output. So couple of observations that were given in the problem. So the start interval is always less than the end interval. If you look at this, the start interval is always less than or equal to the end interval. Okay, and another observation is these intervals are not sorted by any means. So meaning we can have intervals like 15, 18 and then 1, 4, something like this. Okay, so there is no guarantee that all these intervals are sorted. So these are a couple of observations that we can find from the problem. Now let us see how we can solve this problem. Okay, now let us see how we can implement this. So initially, let me take an example of this intervals. So this is the input. If you observe, all the intervals are not sorted here. And if you keep all of them on a number scale of 0 to 20, so 15 and 18 fall somewhere around here, and 8, 10, so we'll take here 8, 10, and 2, 6 is going to be 2 to 6, and then 1, 3, so that's going to be 1, 3. Okay, so this is 4, 2, 6, and 1, 3, and this is another interval, this is another interval. So if you do not sort them, we cannot compare 15, 18 directly with 8, 10 and then see if there is a range or not. So but if you sort them on a number scale, you can see that there is a clear overlapping here, right? But if you cannot sort them, it's difficult for you to identify if there is a overlap or not. Okay, so that's the reason we sort them. Once you sort them, you can clearly see there is a overlap. So the sorted array will look like this: s is equal to 1, 3, 2, 6, 8, 10, 15, 18. Once you sort all the elements, what you'll do is you'll take each and every interval. So initially I'll take 1, 3 as my first interval, and then I'll have a target, and initially the target is going to empty, and we'll put 1, 3 in the target as my resulting target when you only have one element. Now when you move your pointer to the next element, which is 2, 6, and you are at 2, 6, what we'll be doing is, so let me draw the interval. So 2, 6 is somewhere, that's going to be 2, 6. So when you are at 2, 6, what you will do is, like, you'll compare the current pointer's value with the previous pointer's value, which is 3, and if it is less than or equal to the previous pointer value, then what we'll do is we'll just merge these two operations. So as 2 is less than or equal to 3, we will merge 1 and 6. So how do you merge? So basically you update the previous pointer's value, which is 3, you update it to the 6. Okay, so as the element already added in the list, so what we will do is in the target, what I will do is I'll just update this 3 to 6. Okay, and we'll repeat the same process. Now we'll go to the next value, 8, 10. So 8 and then 10, it will be compared against 1, 6. Okay, now is 8 less than or equal to 6? No, 8 is not less than or equal to, so this is not a overlapping, right? So at this time, if this is not an overlapping situation, we will add it as a new item in the target. So this cannot be merged. Okay, 8, 10. Now after that, we will take 8, 10 as our previous interval, and we'll compare it with the 15 and 18. Okay, so I'll take 15, 18, and is 15 less than or equal to 10? No. So this is also not an overlapping. So we will add 15, 18 in the output. Okay, and at the end we can just return the target. So in the code, this is how we write. So we'll take this the current value as previous, and this is going to be current. We'll compare these two values, previous and current, and then check if we can merge. And if we can merge, we'll just merge them. And after that, we will change our pointer. So the previous pointer will be here, and then current pointer will be here. And similarly, we will move our pointers to previous and current, something like that, and then we'll compare each and every value. Okay. Okay, now let us see how we can implement this. So let me take an example of this. So the example is going to be this. So I have taken an example which is not sorted, 15, 8, 2, 1. Okay, first of all, what we need to do is we need to sort the intervals and then do our processing. So before that, the null checks are going to be, if I was given with only one interval, then there is nothing to merge here, as well as if the intervals is empty, then there is nothing to merge. So these are two conditions. So I'm going to write if intervals dot length is less than 2, we can just return the same input, which is intervals. There's nothing to do. Okay, otherwise what we need to do is, first of all, we need to convert this entire intervals into a sorted one. So how do I do it? So I'll do arrays dot sort of, I'll pass intervals as an input, and I'll be using lambda expression to convert this. So that's going to be I1 to I2. So I1 is going to be my first array item, and I2 is going to be my second array item. Now I'll pass it to a lambda expression. So, and I'll do integer dot compare of, now I1's first value and I2's first value I want. So I want to compare those two values. So I1's of 0. So the first array is 0. And then I'll pass I2's 0. Okay. And if you don't want to use a lambda expression, you can also make use of a comparator to do this sorting. And that's going to be something like this. So arrays dot sort of intervals, comma, I'll be passing an object called com. So this is an object of the comparator. So I need to create something like a comparator. This is an interface, and we'll be having of type integer. Okay, so I'll be creating an object called comp, and as this is an interface, if I want to provide an implementation for this needs to be an inner class. So new comparator, and it's of the same type, and I will open these. I'll provide the implementation for this. So the method that we're going to implement is same, the compare method. Okay, so that's going to be public int compare. That's the method which is available in the interface. Now what are the parameters we need to pass? We need to pass the arrays. That's going to be int I1, int I2. Okay, now we can just compare the first values of these two integers and then return the sorted one. So return so integer dot compare I1's first index, I2's first value. Okay, and then you can just do this same process, and this object will be passing it to our sorted array. Okay, now in Java 8 implementation, you don't have to provide all these things. you can just pass these values I1 and I2, and that takes care of it. Okay. So for now, let me comment this stuff. We will execute this one also at the end, and then see how it will work. Okay. The sorted intervals will be looking like this: 1, 3, 2, 6, 8, 10, 15, 18. Now, as the intervals are sorted, what we need to do is we need to perform the merge operation. Now, if you take a look at this, we have to take each and every interval and then merge them. Okay. So initially, I'll take the current interval as a previous interval. One thing to remember, that as we did not know how many merge operations that we'll be doing, we'll have to take a collection. So I'll be taking a list which is of integer type, and I'll take it as a target, and that's going to be new array list. Okay, and initially I will take the current interval 1, 3 into a variable which is, I'll call it as a previous interval, and that's going to be intervals of 0. Next, once I have this interval ready 1, 3, I'll put it in the target. So target dot add of previous interval, I'll add it here. Okay, now I have added, and in my target I have added this 1, 3. So what I need to do is I need to process the next element, which is 2, 6, and then check the current interval's value with the previous interval value. So how do I do it? So for, I'll take integer array interval. So I'll take it as a current interval, and then intervals, and I have named the variable as a current interval. Now what I will do is I'll compare the current interval value with the previous interval value. So if the current interval value, which is 2, if the current interval of 0, which is 2, is less than or equal to previous intervals, which is this one, previous intervals 1th value. Okay, if it is less than or equal to 1th value, then what we have to do is we have to merge. Okay, we'll come back to this one. Otherwise, assume that if this is not less than or equal to the previous intervals 1. So if you take a look at this example 8, 10, this value is not less than or equal to this value. So at this point of time, what we will be doing, we will be adding this as a new interval in our target. Okay, so what we'll be doing is we'll be adding it to target dot add of this current interval. So this current interval gets added to the target, and once you add it to the target, what we have to do is when you move your pointer to this one, you have to make 8, 10 as your previous interval, because you have to compare the 15 and 18 with 8 and 10. So you always have to change your previous pointer value. So the previous pointer value is going to be current interval value. Okay, so you're pointing your previous interval pointer to 8, 10. Okay, if that makes sense. Now let us see how you can perform the merge operation. Okay, so this value 1, 3 is already stored in the previous interval value, and it is already stored in the target. Okay, now what you need to do is you just need to change the value of the previous intervals 1th value 3 to 6. Okay, so that can be done like this. So the previous intervals 1 is going to be math dot maximum of, okay, so that's still going to be previous intervals 1, or this one, the current intervals 1. Okay, and why are we doing math dot maximum here? So you can have another situation like this 1, 3, and then you can have 7, 1 to 7, right? You cannot directly take the current intervals second value always, right? You need to compare 6 with the current intervals, this one, when there is a overlap, and then you have to take the maximum out of it. That's the reason we have math dot maximum comparison. Okay, now we have to return the target in the integer form, and that's going to be return target dot to array of as this is a 2-dimensional array, so that's going to be new integer, and we have to pass the new size of the array. So that's going to be target.size. Target is my list, and then we don't have to provide these columns. Okay, so this is the problem. Let me remove the comments and run the code and submit. Okay, this works. Now let me uncomment the comparator approach that we have seen. So for this, I'll just comment this and uncomment the comparator. Okay. So run the code. There is a semicolon expected. Yes, here. I believe there is a typo. Comparator. There is a typo. Here we go. Let me submit the code. This works. Okay, so you can make use of either comparator, or you can make use of Java 8 Lambda expressions. Okay, that's it for this video, and we'll meet you in the next session. Okay.